Hello everyone, in this episode of my PNS tutorial series I want to talk about the processBlock method and different ways to structure it. And in order to do that we will make a little plugin that has two DSP modules, a mid-side encoder and a saturation unit that only saturates the side, and that will be a nice example for that. So we have a little drum loop here. And we already see that it has some kind of side content in it, so that's cool, we can use that. Now I already made a fresh script that has my default settings, and now we need a new file, or actually let's just write everything in here because we can. So first of all we can make a class that we call mid-side encoder. And then we can maybe add a static method that will we don't even need that, I guess, or will we? Then we would have to use a namespace. Yeah, let's make it this a namespace. Yes. Static void, because then we can call this function without making an object of this. Then it's just like saying this is the namespace of the method encode, and it takes a left and a right sample, and it will modify that, so we have to make this as a reference. So first of all we have to create another variable, I think for the left one, because now we will override the left one by saying left and right divided by 2, or maybe to be a little bit more clean, times 0.5, and then the right is x, which is what was the left before, plus right times 0.5. So now we encoded left and right to mid and side. Now these are technically mid and side, and since we used references they will just be thrown back, and from that moment on this will be mid and side. Now we make the same for the decoder, and this time it takes the mid and side variables and turns them back into left and right, and it's basically the same thing, just with slightly different setup. And without this. Oh, oops, I just saw that I used a float here that was not necessary. So now we have a nice mid-side encoder. And let's just test this for now, so it's clear that it works, because you can never be sure about that. So we just go here, and now for each sample we can just basically say double mid is data samples 0 and current sample. Now of course, in order to make this work you have to have a stereo track, and we would have to check if there is even a second channel in it, but I'll just don't do that now, because we already know that our test track in Cubase has 2 channels, and this is not this video is not about edge cases. So we now take the mid-side encoder and encode them. And now just for testing we will say mid is 0, and now mid-side encoder decode mid and side, And now we will have to overwrite the original samples again. And now let's check this out. Obviously it didn't work because there's always something that doesn't work. Void, reserved keyboard, void. It doesn't like the fact that I used void. Why? Maybe static was not necessary. Sorry for that. I usually use C++ lately, so sometimes things are a little bit different. What? Okay, obviously I kinda did the opposite of what I actually tried to do for some reason, and the reason is because this is wrong and this is also wrong. Okay, now we see that our DSP module in here works, and we have a nice functioning mid-side encoder. And now we will make another little thing. Let's just make that small for now. And now we will make a saturation class. Of course, a saturation algorithm could also just be a single function, but I want to make a specific point here. So now we have a saturation class and maybe a process function. And then let's just make it the same way as we had it before, double with a sample. And this time it doesn't matter if it's mid or side, it's just any sample. And we say sample is a random saturation process. Okay, now we have a nice saturation class and we can just make an object of that. Or maybe we could also pretend that's a namespace even. We could do that, yeah. If you want to work with namespaces, then you could do something like this. And then we would just do saturation process side. And now we would get a saturated signal only for the sides. I don't know if that comes across on YouTube very nicely, so let's make it a little bit more drastic. That actually doesn't even sound so bad. I'm a little bit surprised. Now, the second way we could use all this would be by making classes, obviously. I already hinted that earlier. Classes. Encode, decode. Okay, that can still stay the same in here. Yeah. So that's cool. But we could now introduce the existence of member variables. So we don't have to create X all the time, just overwrite it. I don't know if that makes a difference, but we can do that now. And it's the same for the saturation class. We can just now do stuff like add a drive parameter, double drive, and now instead of hard coding this, we can put our parameter in here, and now we would have a drive parameter that maybe goes between 1.3 and 6. By the way, the reason why I did that is just so you're not confused about the random looking number, but when you use 10H and you write, oops, that's not 10H, then this is the closest to a normal linear function. Or maybe even, yeah, that's also close. But this, I decided that this is the closest for me. So this is pretty much dry and this is pretty much wet. Okay, now we In this kind of implementation, we would have to make objects of the classes. And the advantage of that is now that we have not only the member variables available and maybe even other methods, but also we can make objects of that, even multiple ones if we wanted to. We could have a situation for mid, a situation for side, and so on. And it makes even more sense when we have classes that consist of more than just a method. But for the sake of simplicity, we will just leave it here. And another important factor is that we can now make this way shorter. So now I guess this will do the same thing. No, it apparently doesn't, so something is still wrong here. Let's see. Oh yeah, of course, we don't give the drive knob its value, so let's always at the start of every block give it its value. Oh, I mean, of course, saturation drive. Hey. Okay, so now that would work. But we see that there is this sample loop in here, and it is processed once, and then it just does everything in here. That could become kinda clustered when you have more DSP modules in your plugin than just a mid-side encoder and a saturation unit. So maybe you would like to have a different structure in which every module has its own sample loop. In that case, you could just rewrite this method. Oh wait. Before we do that, let's just do one other example in which we would give a return back from this function instead of letting it void. Then in that case, we would not override sample, but return something. A calculation. We return a calculation. In that case, we would write that side equals this. Now this is maybe a little bit more descriptive because it says it shows explicitly that something changes, while this doesn't look like there must be a change in here, because there are DSP modules that don't change the sound. So this would be a way to make this look a little bit more descriptive. But of course, when you want to modulate multiple values in your method, you can do that. I mean, what would that look like? This is not Python. Okay, now to a different approach in general, which will make the actual classes look a little bit more complicated, but therefore make the process block more tidied up, which, as I said, makes a difference in bigger projects. So in that case, instead of using a sample loop in here, we would have to use the sample loop in our classes. So let's do that for the mid-side encoder. So we would just make our sample loop in here, and then instead of getting these arguments, we of course have to get the data thing in here. So we just get the block data inside of here, and as you know, this is a reference, so it can change the stuff in this object. And now we just take this stuff and put it here, and yeah, I think it would make sense to just write that out now. Oh, oops, of course. And this is 1. Obviously this looks really complicated inside of the class, but therefore it looks a little bit better outside of it. Yeah. Okay, so now I think that's it. And now the same for the other method. That was a very confused way to get it to work. So because the reason why I want to show you this is because this is not self-explanatory, and when I started making plugins I always thought that you have to go through the samples in the just once and then the block ends and it will do the stuff then. And if you like went backwards through this, then it would glitch out the sound. But that's not true. You can just go through all the samples and process them and then just do that again, and it will not mess with your sound. Oh yes, still some, oh no, that's just the X, okay. Oh, I still need an X here. Or did I? Yes. Yes, you always need the X one. Or you can't do that. Okay, that would be it, I guess. And then the same for the saturation process would be a void again. And now for each sample, this time we can actually be safe with the channels. And just say okay, so now what we did here is we made the classes more complicated, but therefore it will be easier in here, because now we can just get rid of all this and just say ms enc encode set encode process and now ms enc decode. Now it looks really easy in the process block, which makes the overview better. Let's test this. Of course, it didn't work. When you make so many changes, then there must always be something that is wrong. Okay, obviously I made a mistake in the mid-side encoder again, and it's the same mistake again. It looks fine over here. Okay. Okay, so that's pretty cool. Now let's imagine that that you don't want to have a saturation unit that goes through the channel, or like any units that have their own channel loop, because maybe you kind of want the channels to be outsourced to the processBlock still, but only have one channel per DSP module. Then you could just take the channel loop and put it here, and then instead of having one saturation, have one sat mid, sat side, and so we need another drive now, obviously. Okay, now we would have, okay, this doesn't make a lot of sense, because we can't use the for loop if it's not an array, but unfortunately in AngelScript you can't use an array of custom objects. But just keep this in mind, because when you switch to C++ later, then you can actually use arrays from your own objects, and then you will come across situations like this a lot. But still, let's just pretend like you could use this channel loop here, and it could just stay there for multiple DSP objects. Then it would be very nice, because you could just say set mid of data and its channel, which would be 0 in this case, and set side process of channel 1, and now instead of having just one argument, we could also have an argument channel, but no channel loop anymore. Of course, now a channel is given by the argument in here, and that will just do its thing, and we have to add another parameter to our stuff. Okay, now let's see if it works. Okay, so now you see that there is even the possibility to put the channel loop before the sample loop, if that makes sense in some cases. And there is no need to put the channel loop inside of the sample loop. It can be the other way around, and it still makes sense. And it's just a matter of taste, and also a matter of the given situation. Sometimes it makes more sense to have the channel loop outside, even though I must really say that most of the times you regret that. But you should be aware that this is possible. Okay, that was everything that I wanted to say for this video. See you